5, 4, 3, 2, 1.
Hi, I am Ray Zimmerman Mancilla of the group 2012 JZ from BSI 2AG2, and I am here to discuss the chapter 1 of Advanced Computer Architecture and Parallel Processing. And here is our outline for the discussion. A. Introduction to Parallel Processing. B. Finn's Taxonomy of Computer Architecture. C. SIMD. D. DIMD. E. Interconnection networks. Computer architects always strive to increase the performance of our computers, especially the speed. A single processor can compute and achieve great performances. For example, the 5.2 GHz processor used in Sony PS3, which is considered as one of the top computer processors nowadays. However, multiprocessing units defies the limitations of single processing units. The combination of multiprocessing unit and inter-network connections produce systems called parallel processors. Before we study the parallel processing, let us take a short view on our computing history. There are 4 computing eras. First, the batch era. It is where computers use punch card, readers, tapes, and disks designed for batches processes only. Second, time-sharing era, where computers use semiconductors, was small, fast, less expensive, and it is only used for company with divisions. Third era, which is called the desktop era, are the computers for company with several departments. And fourth era is called the network era, where the balance of network capacity from processor to centric view to network centric view is reached. This advancement of technology made the use of clusters, or also called the group of computers, to create a parallel processing effective for computing. Now, let us discuss the Finn's taxonomy of computer architecture, which defines the way the information flows to the processor. The information is classified to instruction or data. There are 4 categories of computer architecture. The first one is called simple instructions and simple data streaming. The second one, the simple instruction and multiple data streams. Third, multiple instruction and single data streams. Fourth one, multiple instructions and multiple data streams. Now, let us discuss the simple instruction and simple data streaming. Let us refer to figure 1.1. As we can see, there is the control unit, the processor, and the memory. From the control unit, sending the information to the processor is called the instruction stream. And from the processor to the memory is called data streams. And the other way, from the memory to the processor is also called the data streaming. And from the memory back to the control unit is called the instruction stream. And also, the information coming from the input and output devices are called instruction streams. And that are the information that are going to the control unit. And communication and multiple data streaming. In the MIMD machines, it is made up of multiple processors and multiple memory connected together. It has two categories: the shared memory system and the message passing system. Upon discussion, let us refer to figure 1.6. As we can see, there is the shared memory, the interconnection network, and the processors. Here, in the shared memory system, the processors communicate by reading and writing locations shared in the memory. Well, and we can see on the message passing system, the processors have their own local memory. The processors communicate via sending and receiving operation. Multiprocessor interconnection networks are classified in 4 criteria. First, mode of operation. It is divided into 2 classifications: synchronous mode and asynchronous mode. We can say the operation is in synchronous mode when it uses a single global clock, while in the asynchronous mode it uses hand signals or handshake signals. Another criteria is control strategy. First one is the centralized control strategy, which uses single central control unit. Well, the centralized control strategy is the use of control function distributed among components of PC. Another criteria is the switching of techniques. The first technique is the circuit. The circuit, the complete path and destination should be established first for the execution. We need destination and source. While in the packet switching, the communication between destination and source can change because they are divided into packets. Packets, various communications can change during the execution. Now, 4 criteria is the topology, by 2 situations: static and dynamic. In static topology, the connection is fixed, while in the dynamic topology, the connection can be changed. We have here the examples of topology. For static topology, we have linear, ring, mesh, tree, and hypercube topology. While for dynamic topology, we have the single stage, the multi-stage, and the crossbar switch. Now for the overview, we should be able to be familiar with the advanced computer architecture and parallel processing, because in chapter 2, the interconnection networks in details will be discussed. But for now, this is the end of the discussion of our chapter 1. Thank you for watching.